about technologies for the Internet of Things.
Actually, I'm going to confuse you a bit, and I changed the title. It's more about M2M technology development. I thought that would fit better. Thank you for being here. I was thinking about, will it be full? Will it be empty? I think there is some competition here. Anyway, I'm really happy to see you here, and wonder, how many of you are from local, from Sweden here? So it's a pretty local event. I work in Ericsson. I'm in charge of what is called system area machine-to-machine. It means I work end-to-end with end-to-end issues on a system level. I work a lot externally with external companies, and I try to do things which we don't cover in our product development. I also work together with our different business units and also with the group function, which is within technology, and it's also research. I'm going to go through some of our experiences, what we have found during the time. You may have heard about the 50 billion program, something that Ericsson announced as a vision. There will be 50 billion connected devices, some findings there, and then a bit what we do in research as well. First, I start with our vision. As I mentioned, the 50 billion, there will be 50 billion devices connected, and you can already see today what you have in your home. You probably have more than 10 connected things in your home, in your car, on your body, and so on. And it's not only that we connect our phones and people, but we are now also looking into how we connect the machines as well. And we see that anything that benefits from being connected will be connected, and it creates a lot of innovation when we do so. A few of the enablers which are really, really important is the mobility, broadband, and the cloud. Having those three things, innovation will automatically start. And the innovation is driven from not only one area, but from several areas, from the society, from the people, and from the business as well. And this is happening at the same time. It's not only driven from one end, and it multiplies. People, for example, it's not only professional people, it's also the kids. I think it was 2 years ago, soon 3 years ago, I came to Sweden. I have been living abroad. We were in the car with my daughter. She had bought this iPad with a Wi-Fi connection at home. We went out in the car. She was playing some kind of internet game, and suddenly she said, "Daddy, I cannot play anymore." Yeah, because you lost the connectivity. You don't have Wi-Fi in the car. And then she said, "Why?" Yeah, then you start wondering why. Why shouldn't you have that? So it's not only from technology, from business, the industry, is also from what people are used to. I mean, you're used to have connectivity everywhere. Going into some driving forces for machine-to-machine is, if we start from the bottom, it's more regulatory, it's energy meters and so on. You connect them. You go further, going into optimizing processes. For example, it's logistics, it's fill level in the ice cream box, or you optimize the processes. You continue innovating And then you can see you can create some stickiness. For example, you can have a connection to the end user. A car dealer, for example, a car manufacturer today, they don't necessarily have a direct connection with the end user. But if you create the program, then you can have a connection with the end user. And then you can say, for example, you have to change oil or do some maintenance. Then you can control, where does this car go? Does it go to the competitor place, or does it go to your place to do the service, for example? And then innovation doesn't stop. I mean, it continues. Then you can improve the offerings you already have. And I will continue a bit on this into what happens when you actually start providing end-to-end business, and what are the requirements. There are some very important steps. Here, I come from the mobile industry, and in the mobile industry, we start with the phone, and phone is voice, and it's internet connectivity, it's mobile broadband. But then you move into the area of that you connect devices, and what do you have to do when you do that? For example, you go from best effort to business critical. You go from national to international. It's from telecom to industry. It's a new area. I mean, it's not people talking in phones. It's as Jansin mentioned before, it's construction companies having a camera looking at the construction places and so on. It's not anymore a normal help desk. If you have a mobile phone, you call the help desk and they say restart the phone or something. But if you move into the machine-to-machine area, you need to provide nerd-to-nerd support, real technical support, and it's also 24 hours, 365 days a year. It's a big difference. It's mission critical. You don't have the operator touching the device always, and no keyboard, no display. It's a different world. When working in our 50 billion program, we did some system study, and it's several hundreds of pages and so on, and I have compressed this into one page. So this is some findings. This is what I call the top areas of machine-to-machine today, but it's today. And since there are developers creating new things, this will not look the same tomorrow, I hope. One of the areas is access. Access is not only Ethernet cable or fiber or DSL, but it's also, it's Wi-Fi, it could be Bluetooth, it's Zigbee, and of course it's 3GPP related. It means it's GSM, GPRS, and 3G and 4G technology. We need to include all those accesses and understand what does it mean when you use some kind of access, and what are the different directions you have to take when you develop applications for different access. Another area is secure ID. It's very nice to have your lamp at home that is going on and off from your mobile phone. But when someone else can see that you do that, it's not that fun anymore. Or if someone can control it for you, so the light goes on and off at home, I mean, that's not acceptable. And it's not only for the lamp, I mean, it's also for the missile control, for example. You don't want that push button being connected with Zigbee and no security. So secure ID is extremely important, and it's important end to end. Another one is addressing. We need to have an address, and if we say there are 50 billion connected devices, we need to have an address for all, and IPv4 is not enough for that. So IPv6 is the way to go for addressing. Another one is device management, And I will come back to that later. It's about comparing again with a laptop or a phone or an iPad or something. You have a display, you have some keyboard, and you have an operator. That's you. You are actually operating this one. And you get the question and it says, do you really want to update the software? Then you can press yes, and are you sure? And yes. But in the machine-to-machine world, there is no keyboard, there is no display, and there is no operator. There's no one to pushing the button. So you really need to have remote control, which is remote reset, firmware upgrade, and so on. Next one is automatic provisioning. It has to be zero configuration. You are putting up hundreds and thousands of sensors and lamps and so on in a building, and it has to be made efficient and really cheap to implement. So it has to be automatic provisioning. The next one I have put here is another driver, that is SDK, the development kit. In order to start, I heard earlier presentations where using Raspberry Pi, for example, it's opening up really for the developments to be creative and innovative and so on. But in the connected world, there is no SDK. And we have checked the market, and you can go to some places and you order an SDK. In some places, you get 4 SIM cards. Another one, you get the box. But what you really need is connectivity with the SIM card, a subscription, you need a modem, you need the device needs software, you need the cloud service, and you need an account for that cloud service to start getting going. Those doesn't exist today, believe me. But I want to see them. I would be really happy to see them. All this is driven by pain points and CapEx and OpEx. I mean, it's about cost. If cost goes down, the volumes will go up. And I would like to see the volumes to go up. Examples of device management. Why is it so important? You can do a development of a smart meter, and it will do a remote reading of the electricity consumption. But what would happen if it doesn't work anymore? And if you need to go there and do a reset or update the firmware. This has actually happened, and it has happened in the Nordic countries as well. When you develop the business model and for this project, you have to calculate on these things, but it's very difficult. You don't know it's going to happen. But I mean, what would be the cost? I mean, the cost here would be that you have a guy spending a number of hours per device, including the travel cost and so on. If you have remote device management, then you can minimize these kind of extra costs. So it's very important. Another thing, when you develop applications for cellular connected devices, you have to think about it's not the cable anymore, it's radio, and the radio resources are limited. And there are other things you have to think about. Maybe there are some delays and so on, but resources is one thing. You have battery life probably, and you maybe have a cost. You have an agreement with the operator. You pay with maybe per byte or per minute, or there is always a cost because there is a limited resource. You have to think about that when you do development. I can probably talk about this a whole day, and I will not. So I will take one example. Here in Ericsson, we have something called Smartphone Lab. And in Smartphone Lab, we have created that because we have seen that the development on mobile phones is made in the same way as you do on the internet. And you don't take into the consideration that it's not the cable anymore. And then we invite operating system developers, phone developers to this lab to do some testing. And then we hope that we can get feedback and guidelines how to develop applications. In this case, it's YouTube video streaming, and we have one OS A and OS B, and you can see the behavior on the network. It is showing the network load in terms of throughput during a certain time. And you can see there is a different behavior, and you may wonder, yeah, okay, it's the same number of data in total, but in time it looks a bit different. So what really happens here is something in the background, that the mobile network is optimized for a certain way of communication. It has to be, because, as I said before, it's a limited resources. So if you look in the background, you can see the signaling here is going up and down in different stages. So in this case, the lower case, you have a lot of load in terms of signaling, and which is not good for the operator, which in turn is not good for the end user as well. But with some easy guidelines, you can learn how to make a more efficient development, which is specifically for mobile network. Another one, which you may not know about, is that you download a free application. For example, the application comes with some advertising. And here we have one example only, but it looks fairly the same, or the effect is fairly the same. One application is the one you buy, and the other one is free, but the free one comes with advertising. So what would happen? It's a lot of more signaling on the network, on the mobile network. And what would be the effect then? Yeah, first of all, if you do more signaling and send more data, you will consume more battery, and the battery life of your device will be shorter. So you can play shorter time, or whatever you do, shorter time. The other one is the network signaling. It's affecting the network, and if it affects the network, it affects how many can do the same thing at the same time in the mobile network, and that would in turn somehow affect the price. And that goes also for the data usage. I mean, 161 times the data usage for two applications. One is free, but I mean, is it really free? In the long term, it's not. I mean, something to think about anyway. Now I will move into how we make life easier, and by giving you some tools. I will go into horizontalization, parts we are doing more in research than in commercial products. We would like developers to focus on the application. There is a lot of development going on in the machine-to-machine world, where you do the applications from the base, and then there is one case, one application, then you do the next one, and you do the development from the beginning again. But by putting up some different layers, you can have enablement for different radio protocols, for different legacy devices and so on, into putting knowledge, for example. Okay, we have the base, but then you add some basic knowledge. If you have the basic knowledge here, then you can make decisions, and those decisions, you add intelligence, and if you have intelligence, then you can have machine learning, for example. If you have machine learning, you focus on the use cases. Machine learning could, for example, be you have this thermostat switch in your home, and it's checking your behavior. On Mondays, you're doing workout, so you don't want to have so warm in your home. And then you make it higher and lower, and after some time, it would learn, so you don't need to touch the thermostat anymore. That's one type of machine learning. A few words on what is Internet of Things then. Going back to what I said before, I mean, doing one application for each implementation. There is one way to do it, but if you're really going to press the price down, then you cannot work with stovepipes anymore. You need to do horizontal implementation. You need to add service enablement. That I will come to in a while as well. So using standard, using horizontalization will bring you into the Internet of Things. A bit about devices. There is a lot of available protocols and radio interfaces out there. We shouldn't have the integrators to think about, should I use a Zigbee or Z-Way or Wi-Fi to connect? That should just be plugins. So we need an abstraction layer. We have done development in Ericsson where we have on an OSGI platform, we have done a protocol abstraction functionality that is ready to be brought out to the market today. All devices, even the tiny small ones, can have and should have a web server on them, which enables web development environment. You shouldn't have to study thick books to do the development on the devices, but if you use standard tools, then development can go on. It will be cheaper. Another thing is, we have seen you can come down very low in footprint. Going out to billions and billions of devices, you need to really squeeze. And what do you need to squeeze is actually the silicon area. And how do you squeeze the silicon area? You do that by having a small footprint in memory, for example. And we have seen implementations using 48 kilobyte of flash and 8 kilobyte of RAM. With the web server running on that, and the OS is Contiki, for example. And if you have that, then you push the silicon area. Silicon area is cost. Cost becomes price. You also need to look into the value chain. And I mentioned service enablement before. Look into the different layers you have, starting from the devices. I think I have mentioned some about the devices. Then you have a connectivity. And then you have something called service enablement. What is service enablement? Yeah, service enablement is service enablement and is application enablement. That is the horizontalization of what you do again and again. But you shouldn't really have to do that thing again and again. So that's why you put the layer called service enablement. You can see another thing here. If you're looking where the money is in the industry, it is basically not in making the devices or the connectivity, but it's in the application and the service enablement. That's where the market will grow and the money will grow. Again, our vision is 50 billion connected devices. We would like that to happen. I have gone through a few enablers and a few problems and how we can solve them. It's about connecting devices in machine to machine, and anything that benefits from being connected will be connected. If you found this a bit interesting and you wonder where to go, I will show you two places you can check. One is Ericsson Labs, where you can see some tools you can use, and you can also, there is a community that you can utilize. Another thing is a network society. You heard me mention that name. Here you can see some more explanations of what I have told you. That was all from me. Any questions or comment?
I have a question actually. You talked about the SDK, and
yeah.
How much involvement does Ericsson have in this? Are you something that you're working on, or?
Yeah, actually we do. And the thing is not that it's our core development, but in order to make things happen, we need to be involved in the industry, and there the minimum thing you can do is to see what's out there. And for me, this SDK is actually the whole package. If you get the whole package, then you can start development and you can start innovation. So what we have done is that we have had a team doing an investigation of what is available on the market, and they have also put something together. It will not be something we will bring to the market, but it's typically something that we can reuse when we support our customers. So that's how far we will take that. But it's really amazing when you go to the web pages and it looks very nice, but then once you order, you get only a part of it. The other way is that I talk with some distributors who try to help machine-to-machine developers. First of all, they tell me there are 40,000 companies in Europe only integrating these machine-to-machine devices. So it's a long tail. But then they tell me that, okay, we need to source from 10 companies to make an M2M device. Imagine when they come to the antenna, there is no energy left. I mean, if it's black in one end and gold in the other, who cares? I mean, that's enough. So I think it's really good to have a good SDK. It's getting better, and like I said, it's the important areas of today. It will be better, but it's not there yet. It's a long answer, but I hope it answers your question.
Maybe we hear anyway.
I can hear you, yeah.
We are talking about the SDK, and I was a bit confused because for me as a developer, SDK is done on the device that you app with. And I think you mean that the SDK should have solutions for the device management and the connectivity that is that.
I think it's an excellent question, and of course, this is a forum for Java development. I'm really happy you asked the question. I mean, the question is, what is actually the SDK? And it's a system development kit, and within the system development kit, you would also need the SDK for certain environments. But when I say SDK, I include all the parts you need to do to make a complete solution. So it's a system development kit.
Then there's another question. Where is Ericsson? Where do Ericsson have a position today to grab the market?
So in relation with the SDK, Ericsson provides managed connectivity solution to the operators. So the operators are our customers. And the commercial product is called DCP, is Device Connection Platform, and it provides stability, reliability, and wholesale. And what does it mean with wholesale, for example, is that in machine-to-machine, you don't order one SIM card to one phone and put it into the phone in the shop. You would like to order 10,000 or 100,000 SIM cards, for example, or subscriptions. Otherwise, what would happen is that you end up with this pile of envelopes, and in the envelope is a big SIM card, and in the big SIM card is a small SIM card, and then you need to push it out and put it into your device, and your device is actually waterproof, so it's not waterproof anymore. But anyway, that's one part. The other part is that we provide APIs for the developers. So for the cloud services and also for the devices, this managed connectivity, we provide APIs. And also as I mentioned, application enablement and service enablement is APIs for the developers that we provide.
Did you say those APIs are
And I mean, what I showed you was this development we had done on the gateway, and there they are, yes.
What type of services are you enabling on the gateway?
I mean, on the gateway, and that is a research project, and the service is actually straight to the devices. So it's a stupid device, if I may use that word. And then you have the sockets to each of the sensors or the actuators. So it's a lamp on, lamp off, and it's reading the switch if the switch is open or closed, and so on, temperature. So in that case, it's a quite simple one. If we move up in device connection platform, for example, which is the product we put in the operator's network, then the features would be, for example, set a limit for how many SMSs is sent every day, or that kind of features. So it varies. But please go to the web pages, and you can find hopefully interesting things.
Thank you, Jan.
Okay, thanks a lot.